Hi, this is Sean Chua from simplecamconcepts.com. Today I'm going to share with you on the group trends of group 7 elements of the periodic table. They're also known as halogens. At the end of this video, you will learn 4 trends of the group 7 halogens that are heavily tested in the examination. And the first trend that we're going to talk about is the size of the diatomic molecules, which tends to increase as we go down the group. This is because as we move from fluorine atom to the chlorine atom to bromine atom, there's always an increment in the number of inner shells. As the inner shell increases, the size of the halogens will increase, and this will cause the diatomic molecules to become bigger and bigger in size. So the size increases down the group. This is the first trend. Now the second trend that we tested is on the color. We'll take a look at the color of the individual halogens first. Fluorine is pale yellow in color. Chlorine is greenish yellow in color. Bromine is known to be reddish brown. Iodine is purplish black. Sometimes you see them in textbooks and assessment books to be dark violet. Astatine is black in color. So as you can see, from the top to the bottom, as we go down group 7, the color of the halogen increases. So we say that the color becomes darker as we go down group 7. So this is the second trend that will be tested. The third trend will be on the physical state and thus the melting and boiling point. Fluorine is a gas at room temperature pressure. Chlorine is also a gas. Bromine is known to be a liquid. Iodine is a solid, and astatine is also a solid. So from the top to the bottom, you can see that the melting point and the boiling point increases as we go down group 7. This will be the third trend that will be tested. The fourth trend will be on the reactivity. Let us now take a look at the fourth trend of your group 7 halogens, and this will be on the reactivity. We're going to choose 2 examples right at the top. Fluorine, atomic number is 9. Chlorine, atomic number is 17. So the electronic configuration will be 2.7 and 2.8.7 respectively. We're going to draw the electronic structure to have a clearer view. So fluorine will have 2 shells. Chlorine will have 3 shells. Now, for your group 7 halogens to react, it essentially means the ability to accept an electron to be placed on the outer shell to get a full electronic configuration. So for it to react, it means adding an electron from the outside and for it to be attached to the valence shell. So how can this be attached to the valence shell? There is a positive charge in the nucleus for an atom. So what happens is the electrons will be attracted by the positive charge in the nucleus. Take a look at the distance. You realize that as you go down the group of the halogens, the distance between the valence shell and the positive charge in the nucleus is getting longer and longer. This also means there will be less attraction for the added electron to the positive nucleus. Thus, the reactivity decreases And the fourth trend will be reactivity decreases down group 7, and we expect fluorine to be more reactive than chlorine, to be more reactive than bromine, to be more reactive than iodine, and the last one will be astatine. Now in the exam, if you are asked to use equations, reactions to show your understanding of the trend in terms of reactivity, we tend to use this reaction known as halogen displacement reaction. Let me give you an example. Let's say we add chlorine gas into sodium bromide solution. We'll expect it to have a reaction. Since chlorine is more reactive than bromine, as you can see, so chlorine will displace bromine out of sodium bromide, and we get sodium chloride solution and bromine solution. To balance it, it looks like this. Alternatively, if I add bromine liquid into sodium chloride solution, there will be no visible observation because bromine is less reactive than chlorine. So we will not be able to displace it. So there's no reaction at all. So in this case, you can show to the examiner that you understand halogen displacement and how reactivity of group 7 decreases down the group. I hope you find the learning in this video useful to you. Feel free to share with your friend and welcome you to look at more videos at simplecamconcepts.com. I'll see you there in the next video. Thank you.